Time-lapse photography of night sky is becoming very popular nowadays. Both professional and hobby photographers are getting interested to make more nightscape imagery, especially in time-lapse. Because of longer exposure in real time, nobody can realize the motion of the sky caused by the Earth rotation. Depending on how long the exposure is, you can capture much deeper details of the night sky compared to real-time video. It's almost impossible to capture the details of the Milky Way we can see in time-lapse video with current technology of real-time videography. The images taken by photo cameras has much larger resolution compared to video cameras. So instead of shooting only in Full HD, for example, with normal DSLR cameras, you can go up to 4K or even larger in videos when you're shooting in time-lapse. Many of time-lapse photographers who are doing this more seriously, they're using motion control systems from dolly rails, which the camera can move couple of meters or more, to panning and tilting devices in various axes. But once you have a tracker, star tracker like Polari, you can also use it for panning or tilting in a time-lapse motion. So you can turn your normal star tracker mount for astrophotography to a panning device for time-lapse motions. The general idea behind this is to just let the tracker knows that we are located on the pole, on the Earth pole. So that means the Polaris, for example, the North Star, is located up at the zenith overhead. That means a tracker like this needs to point upward, because this is the hole that you need to look through and find Polaris. So from our location, as we are introducing to the tracker, Polaris is at the overhead. So at the North Pole, when Polaris is looking upward, tracker tries to rotate around and just follow the stars. The stars in the poles of the Earth are just rotating horizontally above the horizon. This is what the tracker is going to do, just follow the stars along the horizon, and that's exactly what we need for a time-lapse motion in panning. You can also use your star tracker mount, Polari, for tilting upward or downward. That's another creative use of the tracker. And in order to do that, you just need to introduce Polari that we are located at the equator. That means Polaris, for example, is right at the horizon. Therefore, the tracker will be vertical like this. And then if you point it this direction, that means this is north, this is where the Polaris is. So when the camera is just shifted 90 degrees from the north, it's either looking west or the east, because the stars at the equator are rising or setting very vertically over the horizon. So when you're introducing the tracker that we are looking west, for example, these are all imaginary, supposed, because you can point it any direction. You can just give it this direction, then this becomes north, and 90 degrees from this can be west or east. So then the tracker would come upward or downward. The most common use lens in time-lapse photography is generally in the range of 14mm to 24 on a full-frame sensor camera. So that means in 14mm you have almost over 100 degrees horizontal field of view, and in 24 it's about 70 degrees for a full-frame camera, and almost 30% less in many of the crop sensor cameras. And something you need to calculate before doing the motion is that how fast Polari is going to pan across the horizon. So usually any star tracker mount is following stars with the speed of the Earth rotation, which is 15 degrees per hour. That's why in 24 hours we have 360 degrees one complete rotation. So the normal speed of Polari is 15 degrees per hour. That means in 6-7 hours you can go through a whole field of view of a 14mm lens. But there's also a faster speed in newer generation of Polari 2X made mainly for time-lapse imaging, and that's best for wide-angle lenses. So it goes up to 30 degrees per hour in this speed, and you have also half a speed which goes down to 7.5 degrees per hour, better for higher focal length lenses.